Welcome, Algebra, to our next video on geometric sequences. And this follows up our arithmetic sequences that we worked on last class. And this marks something very new for us. It's a very different type of pattern, type of equation, and we'll get into that here. Your learning target is I can identify and create an explicit formula from a geometric pattern. So we did something very similar to this last time, but it was with an arithmetic pattern. Alright, so a geometric sequence, and think back to how this compares to arithmetic sequence. It says it's a sequence of values that follows a pattern of multiplying by a fixed amount times each term to arrive at the next term. So last time it was about adding something to the last term to get to the next term. The number multiplied each time is always the same, just like how before there was a common difference. This time it's called a common ratio. Sometimes it's called a common multiple, but it's common ratio. Alright, so the first thing we do is just kind of practice finding that common ratio. So here's a good example of a geometric sequence, 4, 12, 36, 108. It continues from there, it gets bigger and bigger. But notice it's getting bigger faster than an arithmetic pattern does. An arithmetic pattern is very controllable. You can kind of see it go up. We realize it made a line. It's very predictable. Where a geometric pattern kind of gets wild at the end. It just kind of gets bigger and bigger and bigger every step. So in this bubble over here, you see it says to find the common ratio, divide the second term by the first. So here's the second term. Here's the first term. We're going to do 12 divided by 4. So 3 is the common ratio. And it says by the second by the first is usually the easiest because they're the smallest numbers potentially. But you could do any number divided by the one before it. So I could have done 108 divided by 36 and I still would have gotten 3. But they do need to be next to each other. And we have a formula for this one. So this looks somewhat similar, not really I guess, to the formula we had last time. It has a couple of the same elements, the A of n, and A1. So it says formula for any term. And again, we'll go over these parts, what they mean. A of n means the nth term. And A of 1 means the first term. And then R is that common ratio we just found. N is the term number. So these are the things that usually get people in the beginning when they haven't really figured out all the terminology yet. But we'll really be careful with how we say these things as we go through the examples. Alright, so that's going to come back in just a minute here. Let's try to find, this is just more common ratios. So we don't really need a whole lot of practice with this, but take A for instance. Now that the numbers are going down, they're getting smaller, and we still do the second divided by the first. So that's 50 divided by 100, and that's 1/2 or 0.5. So sometimes you just get a smaller number. Don't look at it and say, 50 to 100 is times 2, so it's 2. Don't just switch directions because that's easier. Alright, the next one, again, take the second one, divided by the first one, and you get -3. And that makes sense. Every time it looks like I multiply by -3 to get to the next number. And then C. Same thing, I want to take the second one, 90, divided by the first one, 120. You can reduce it really quick like that, so that's 9/12, but we can go further. 3 goes into both of those, so that's 3 goes in 9 3 times. 4 times, so 3/4 or 0.75. And you can test it. I always like to test it a couple times, especially if it's a weird number like that or a decimal. I take 67.5 and multiply by 0.75 to make sure that I get 50.625. And if I did, I'm pretty darn sure I did it right. Okay, so this slide we have find the 10th term. Now, we could just continue this pattern all the way out to the 10th term if we wanted to, but things get really big really fast and really small really fast. And with a calculator, it's not the worst thing in the world to just do the same thing a few more times to get to the 10th term. But eventually it's going to ask you, like, what's the 100th term? And you don't want to sit there with your calculator hitting a button 100 times. So instead, we make a formula. And if you remember, the formula was the nth term, because that's ultimately what we want to do. We want a formula that's going to tell us whatever term we plug in. So if I want to find the 10th term, I want a of 10. If I want the millionth term, I want a of a millionth, and I don't want to do something a million times. So I want the nth term, and it's going to be the first term multiplied by that common ratio to the exponent of n minus 1. Alright, so the first thing we do is part A is figure out what that r is. So I have 12 divided by 4. Looks like the same pattern here. 12 divided by 4, and that was 3. So I know 3 is going in this spot. I know that n minus 1 is just going to stay there because if I'm just making the formula, just in general, this is the explicit formula, I just want to leave n by itself, and then we'll plug in something in a minute. A of 1 is the first term, so right here is a of 1. Remember, this is a2, a3, a4. What it's asking us for is a10. And we're going to put 4 right there. So this is the explicit formula. This is, you can hand this formula to someone and say, here, now you can find any term you want. We want to find the 10th term, so this is what you do. You say a of 10 equals 4 times 3 to the 10 minus 1 power, which is 4 times 3 to the 9th power. And we're going to want to calculate for this. Alright, looking at mine, it's 78,732. And yeah, it's a big number because every time you multiply by 3, it just keeps getting bigger and bigger and bigger. And at only 10, it's already almost 100,000. And we'll be far beyond that at 11. Alright, let's try it one more time here. And we have negative 4, negative 8, negative 16. Looks like it doubles every time. Negative 8 divided by negative 4 equals 2. So when I write my formula, we like a line here. It's going to be a of n equals the first term times the rate, the n minus 1. I'm going to fill in what I know. Leave a of n. The first term is negative 4. The rate is 2 to the n minus 1. There's my explicit formula. Now I want to be specific. So I'm going to say a of 10 equals negative 4. 2 to the 9. I'm just going to skip a step there. And again, we'll need our calculator for this. And mine says negative 2,048. So these are our 10th terms. Alright, we're going to skip letter C though, and we're going to move on. And this one, they start you off with 2 parts of an equation, and they want you to find the first 5 terms. This is actually a little easier. So if the first term in the sequence is 1, and the common ratio is 6, to get my next value, I multiply by 6. So I have 6 here. I have 6 times 6 is 36. And then it immediately goes to where I don't have things memorized. So I'm going to pause it, finish out the rest of it, and see if you can get the same thing. Alright, and there it is. So we really only had to find 4 more terms, but they gave us the first one. So again, that's super easy. I'm not even going to do B. It's really easy once they give you the information just to make a sequence. Okay, here's one of the more confusing kinds of questions they could ask with sequences. Oh, new email. Looks boring. And what it is it's like a fill in the blank. And a lot of kids can get this without really doing what they're supposed to. They can kind of guess at it until it comes out right. To get from 1 to something to negative 8, I know that it's probably going to have to be a negative number. And then you can just kind of experiment with numbers until it works out. And I can kind of already see what they're supposed to be. But I want to show you the real way. And we start with the explicit formula, So let me write this out. And I'm going to fill in some things that I know. I know what the first term is. It is 1. I do not know what the common ratio is. If I knew what the common ratio was, I just really easy just do 1 times that, and then that times the same thing again, and get it really quick. But what I do know is I know what the fourth term is. I know A1 is 1. I'm missing A2 and A3, but I have the fourth term, A4. So what I'm going to say is, since A to the fourth equals -8, I'm going to replace this with -8. This is the nth term I'm looking for, and as long as I fill in n with what made it -8, which was a 4, then I'll get the rest of it. So here's r is missing, and I'm left with, let's see, this is 4, I said, -1. So we get -8 equals, now 1 times anything is just itself, so I just do r to the 3rd power. And I have to think to myself, what can I cube? What can I multiply itself 3 times to get to -8? And you can do this in your calculator too. This is called a cubed root. That's the opposite of cubing. So you have to do this. We'll see this in class, but if you look at the calculator and you hit the math button, right in that list that pops right up is a cubed root thing. It's at number 4. Kind of looks like this. And you can use that. The one down below that, it says x root. And you can take the whatever root. You can take the 4th root, the 5th root, the 6th root. It all depends on what the exponent is. But for now, we're only going to need the cubed root. And we get, let me actually write the way it will actually look like this on your calculator. And you get a -2. So r equals -2. And you probably all could have guessed that without a whole lot of help. But that's not the answer. It says find A and B. We just found r. So I know that I have to multiply by -2 to get A, which is -2. And then I have to multiply that again by -2, which is a positive 4. So there are my A and B. Alright, let's try this all over again with this bottom one. And I have my A1, I have A4, I want to find A2 and 3. Write my formula down. Fill in what I know. I know that the 4th term is 54. So the nth term I'm looking for is going to be, not what I'm looking for, but what I have is 54. The first term is -2 this time. Again, r is what I want to know. And since I used the 4th term, n is 4. So we say again 4 minus 1. And we get 54 equals -2 r to the 3rd power. And I first have to get rid of this -2. So I'm going to divide by -2. And I get -27 equals, r to the 3rd. And again, on the calculator, you would type in that cubed root button, or you might just know it off the top of your head because it's a pretty small number. But you show the work by doing this. And you should show it on your paper. Even if you know what you're doing, that's how you show the algebra. So these cancel, and you get r equals -3. So and I circled it, it's not really my answer though. I need to use that -3 to find the rest of it here. So -2 times -3 gets me A equals 6. And then -3 times 6 is -18. So those are my 2 answers, A and B. I always check it one more time. I say -18 times -3, and if I get 54, I'm in luck, and we do. Okay, we're going to do part B together in this, and that's the last thing we're going to do. I'm going to leave part A for you to do on your own, and something that we'll talk about in the beginning of class. Alright, so part B, again, this is kind of back to a couple slides ago where we said to find the formula. This one kind of says two things. It says find the common ratio, which we'll need to do anyways, and write the nth term. And they give us, in part B, they want us to find the 7th term. So a part of that is going to be writing the equation. So here we go. Second divided by first, 4.5 divided by 1.5. This is to find R, and I believe that's 3. Alright, so even though your decimals, the R is a nice whole number. A of n equals 1. Some kids ask me, oh man, are we going to have to memorize this? And I just tell them, you will memorize it on accident. You'll use it so often that it really, well, it's not a thing you have to try to do. And then A of n, I'm going to leave. The first term would be 1.5, common ratio 3, and n minus 1. Again, that's the explicit formula. That's all you have to do for this formula. But we want to find a specific n value, the nth term of 7. So the A of 7th term, that's not how you say it, A of 7, or the 7th term, is 1.5 times 3 to the 7 minus 1, which is 6. So in the calculator, I'm doing 3 to the 6, then times 1.5. 3 to the 6, 729, times 1.5. And that's 1093.5. And that would be the 7th term. So you're going to do the exact same thing for part A. You're going to find the 12th term, along with finding the explicit formula along the way. So just so we know, because we write this kind of in a series of these 4 things I have here, and I just want to make sure people understand the parts that are important. This is just the general formula. So we'll call that general formula for any geometric sequence. This is the explicit formula for this sequence. I'm going to write that for this sequence. This is just plugging in. So that's not really it. That's never going to be an answer to anything. And this is the 7th term in the sequence. Sometimes you see all these things and you wonder, like, which ones do we need? And it depends on what they ask you. If they say, write an explicit formula for this sequence, you want to go with the second one. If they say, find the 7th term, your only concern really is that that last one is correct. Okay, good luck. I will see you in a couple days. Have a wonderful night.